Today I will discuss about shear force and bending moment diagram for cantilever beam. First of all, a cantilever beam carrying a point load at its free end. Look at the board please. A cantilever beam AB carrying a point load W at its free end. Suppose the length of the beam, that is L. Now we have to calculate SF and BM diagram for this problem. And remind, don't write something below this diagram, as we have to draw SF and BM diagram. Now calculate the value of shear force, and also remember all the calculation from right to left, that means free end to fixed end. So shear force at point B, that is equal to W. As we know that shear force, sign convention for shear force for cantilever beam, that is plus. So W. Now consider a section capital X at a distance small x from free end. So shear force at this section, that is also W, as this force is distributed throughout the length of the beam and concentrated at the fixed end. And so shear force at fixed end A, that is equal to also W, as there is no shear force, no load here. Now draw the SF diagram. First of all, from every point draw projection line, that means light line. This is a reference line A, X and B. Should be remembered, for cantilever beam carrying point load, shear force is always vertically upward and BM should be inclined downward. Remember. So for this point load, here shear force at point B, this is W. So here vertically upward. This is W. And here also shear force at point X, this is W. So here also it is W, and at fixed end this is W. So here also this is W. So if you connect this point, you will get a straight line. So this is actually shear force diagram, and here it is positive and section line. Section line means light line, 45-degree angle, 2 to 3 millimeter gap. This is section line, and this is shear force diagram. Now calculate bending moment, and you should start from free to fixed. So bending moment at point B, and you know that bending moment for sign convention for cantilever beam, it is always negative. So at point B, this is the force W, but here there is no distance, as you calculate all the distance from free to fixed. So at point B there is no distance. So BM at point B is 0. Now bending moment at point X. First of all, minus load at point B, this is W, but you take moment at point x. So this is distance x. Force into distance is moment. So here W into x. Now at fixed end, bending moment at fixed end, that is force acting at point W, and this is minus, and you are taking moment at point A. So the distance is L. Yeah. So this is minus WL. Yeah. And the diagram is negative. So here it is reference line AXB. Yeah. And here look at here. This is bending moment for point load. This is inclined straight line. At point B, this is 0. At point X, this is WX. And at point A, this is WL. Yeah, and it is gradually increased. So this is actually inclined straight line here. Here the value, this is WX, and here the value, this is WL. Yeah, and this is negative, and here section line. Here section line. Okay, this is BM diagram. BM diagram. Yeah, and should be noted negative sign due to hogging. Yeah, hogging means negative moment. Yeah, this is SF and BM diagram for cantilever beam carrying a point load at its free end. Okay, now another problem. Yeah, another problem. Read the problem. A cantilever beam 1.5 meter long. Yeah, problem 1. A cantilever beam, first of all draw the diagram. A cantilever beam 1.5 meter long. This is 1.5 meter long. Okay, it is suppose AB. Carrying a point load of 1000 kg each. Every load is 1000 kg at a distance of 0.5 meter, 1 meter and 1.5 meter from the fixed end. That means from the fixed end, this is 0.5 meter, this is 1 meter and this is 1.5 meter. And here this is load 1000 kg. Here this is load 1000 kg, and here this is load 1000 kg. From the fixed end it is 0.5. Yeah, this is 0.5. That means here this is 1 meter and this is also 0.5. That means from fixed end this is 1.5 meter. Yeah. And here this is CD. Now at first calculate the value of shear force from free to fix. Yeah, look at the board. Shear force at point B, this is 1000 kg. Yeah, at point D, shear force at point D, previously this is 1000 kg, and now at point D this is 1000 kg. So this is 2000 kg. Yeah. Next, shear force at point C. Here this is 2000 kg. That means up to point D, here the total load 2000 kg. Now the next load, this is 1000 kg at point C. So up to C from free end, this is 3000 kg. Yeah. Now shear force at point A. Here this is 3000 kg. up to point C, and from C to A there is no load. That means here at point A this is 3000 kg. Yeah. Now draw the SF diagram. From all the point, first of all draw projection line. Draw projection line. Now this is reference line A, C, D, B. At point B, this is point load 1000 kg, and so it is vertically upward, straight line. Yeah. So this is 1000. Yeah. At point B. From B to D, this is a straight line. Here, as from B to just D, there is no load. So this is a straight line. But at point D, 1000 point load is acting. So at point D, this is 2000 kg. And due to point load, again it is upward. That means here, this is 2000. And similarly, this 2000 kg advances up to point C, and when it touches C, again 1000 kg is acted. So again it is vertically upward. This is 3000, and here there is no load. Yeah. So at fixed end, this is 3000. This is 3000. Okay, and it is positive, and section line. This is light line. Yeah, and here this is shear force diagram. Yeah. Now calculate the value of BM. Calculate the value of BM, bending moment, and you should calculate from free to fix. So at first, bending moment at point B. Okay, first of all, negative load, this is 1000, but there is no distance here. So this is 0 at point B. Okay. Now at point D. Okay. At point B, this is 1000. First of all, minus, this is 1000. This load is acting at point B. And you calculate moment at point D. So this is distance 0.5. Yeah. And this moment is acting at point B. At point D plus at point D, the load is 1000, but there is no distance. So here this is minus 500 kg meter. Yeah. Now at point C, BM at point C. First of all, minus. Okay. From free to up to C, all load is to be considered. Yeah. First of all, at point B, this is 1000 acting at point B and taking moment at point C. So this distance is 1 for 1000 kg. Plus this 1000 kg is acting at D and taking moment at point C. So the distance 0.5. So 1000 into 0.5. And up to, from free to up to point C, at point C, this is 1000. This is 1000, and there is no distance for this load. Okay, as the load is acting at point C and you are taking moment at point C, so there is no distance. Yeah. So here calculate, this is 1000 and 500, that is 1500 kg meter. Okay. Now BM, bending moment at point A. First of all, minus. Yeah. Okay. At free end, this is 1000. At free end, this is 1000. Acting at point B and you are taking moment at point A. So the distance 1.5 for this load. Plus for this load 1000 kg. This is acting at point D. You are taking moment at point A. So the distance 1. And For this load acting at point C, taking moment at point A, so the distance is 0.5. That is 1000 into 0.5. So the total, this is 1525, that means 3000 kg meter minus. Yeah. So this is these are the values of bending moment. Now draw BM diagram. This is projection line. This is reference line A, C, D, B. Yeah. At point B, this is 0. At point D, this is 500. Yeah. And due to bending moment, it is inclined straight line. So it is inclined straight line. And here the value 500. At point C, this is 1500. Okay. So this is 1500. And connect this point. Yeah. This is 1500. And at point C, this is 3000. This is 3000 here. This is 3000. And this is negative and section line. This is section line. Yeah. And this is BM diagram. And negative sign due to hogging should be mentioned. Yeah. This is the SABM diagram for this problem. Yeah. On the next day, we calculate SABM diagram for cantilever beam carrying uniformly distributed load. Yeah. And also we will drill the problem of cantilever beam carrying point load as well as UDL. Okay. Thank you.